Vy vx, right? We have to differentiate this 2x to the power 3 minus 5x to the power 3 plus 2 all over our ax. Remember, we're not using the first principle, but that will take us a lot of time. Using the first principle is going to take us a whole lot of time. So that is why basically many times we don't use it, especially the jam bites. You basically don't need the first principle in that sense, but you need to understand how the first principle works. Is very important for later use, right? So remember, mathematics is always progressive. So that's all you can take note of. Mathematics is progressive. Move from one stage to the other. So now look at Alex. What am I going to do here? No differentiated guide. Remember, I was saying this till it comes down. Okay, I'm gonna have 2 till it coming down. Then I have x 3 minus 1, right? Minus these 2 come down 5, 2 coming down, and I have x 2 minus 1. So these 2, whenever I differentiate the constant, I'm going to get what? 0. Of course, this thing means 2, 0, x 0 minus 1. Of course, 0 times 2 is 0, right? Times x is 0. So there's no need. That's why they said if I differentiate a constant, I'm going to get what? 0. I believe that's clear now. Every constant is anything to the power 0 is what? 1. So x to the power 0 is 1. 1 times 2. So there was this constant here. So basically, it's simply telling us that if I'm differentiating this guy, this 0 is going to come down here. I'm going to have 2 times 0, right? And then x 0 minus 1. So of course, which we result towards is 0. Okay, so we have 6x squared. 3 minus 1 is 2 minus 10x is to power 1, right? So it becomes my answer. So in the y dx becomes this. I differentiate y, we'll expect to x. You're going to have something like x. And have the second one. Dx raised to power t plus 1, right? So x. What am I going to do? And you can click. But if you feel this one, I can change this one. Now I have 1 over x. 1 over 10 is the same thing as